Alright. So what we're going to start off doing is 2 times minus 2 squared. So, and then minus 5. So if you remember vid maths, indices first. So it'd be like 2 times, and then minus 2 times minus 2 is 4 minus 5. So it'd be 3. Yeah?
Perfect. Okay. The hardest thing there, you start off with the hardest one, go to the minus. It's the minus 2 squared gives positive 4. That's what people are going to chuck up here. But remember, we know what that graph looks like already. We know it's going to be U-shaped. If it wasn't a U-shape, it should be an indication you've done something wrong to go back and look at. Okay?
Hang on, I don't know what I'm doing now. Oh yeah, right. So, and then you want to do 2, because you're going to do this one now, aren't you? So 2 times 1 squared minus 5. 1 squared is quite a hard one to do, so 1 times 1 is 1.
Oh boy.
Right, and then 1 times 1 goes into 1. Get it? It's quite difficult with multiplication, but whatever. Right, and then 2 times 1 is 2. 2 times the 1 by 2. Yeah, you get the point. So it's 2 minus 5, and then that equals minus 3. And there you go. Do you want to do the graph as well?
Yeah, if you don't mind.
Yeah, I don't.
You need to move the camera down a little bit. That's it, perfect.
My fingers. Right, we'll have the question in so everyone knows. Right. Well, it's already been drawn in. Simple. So if I zoom up and is there any way I can put like the graph?
No, it's a little bit annoying. Don't worry, we've got the table now, so don't worry, just focus on the plotting the coordinates bit.
Can I do it like that?
Oh yeah, there you go.
A genius. Okay. So x across, y z. So x minus 2, then there's the 3. So you do a star. Minus 1, minus 3. Oh. Oh, yeah. And then yeah, and there you go.
So how would you use a ruler to join those points up there?
No.
Good. It's going to be freehand curve, okay?
Can I ask you a question though? Like, it doesn't ask you to draw a line, so why would you even draw a line if they're not even asking you to draw a line?
It says draw the graph. Yeah, drawing the graph means that you don't just plot. It's not like a scatter graph where you just plot the points. You'd actually go and then draw the lines.
For people who do
yeah, it probably will ask you a question, but I think I did scan it a little bit further down. So it's about where it crosses the x-axis. Yeah.
So I would join up the stars individually so you have a nicer circle. Curve.
Technically speaking, you should try and do it in one continuous go, but I'd actually do what Ruth did. And she stopped at the minimum point, which is this point here, the lowest it goes down. So we've seen a couple of questions come up recently, which is like, what is the minimum point of this graph? The minimum point being -5 or 0 -5 and stuff like that, so you could get asked that as well. I'll jump into the next bit, but thank you very much.
That's cool stuff, anytime.
So the next bit then asks, it says, write down the x coordinates, so notice there, coordinates, of the points of the intersection y equals 2x squared minus 5 with the x-axis. So that is just here and here, so you just need to read those points off. So that's minus 1.5, so minus 1.6, and I think 1.6. Okay? Oh, there you go. Part D, write down the minimum value of y. Minus 5. Okay? All good? Yes, sir. Oh, yeah. So if you've got like 1.5, they'd probably say in the marks you can accept anywhere between 1.5 and 1.7. And then same for the minuses. Okay? It's a bit of a swine to put in written of communication on this one as well. Some of these are quite easy to fill in, some of them are quite hard. I might stick and do this one myself. It says so these cards are written in ascending order, so smallest to biggest. I'm told what the large number is by here. It says the large number is 16, so I can go and write that in straight away. The median is 10, so that means I can write 10 in the middle. The range is 12, so 16 take away something is 12, so that means that it must have been 16 take away 12 was x, so x must have been 4. Okay, it's the other bit that's really, really hard now, okay? Now I've just used x. I don't know what this number is, so what should I call it?
X.
I've just used x.
Y.
Okay? I could use any letter though, okay?
B.
I'm told that the fourth number is twice the second number, so shall I call this z?
2y.
Brilliant, well done. If you called it 2z, you couldn't solve it. It's twice that number, so it's 2 lots of y. Okay, and the mean is 9.6. So the mean is when I add up all the numbers together, so 4 plus y plus 10 plus 2y plus 16, and I divide it by how many there are, so 1, 2, 3, 4, 5, and that comes to 9.6. Okay, so take the divide by 5 over, it becomes times by 5. Just giving out a shot here. And then 4 plus 10, 14, plus 16 is 30, and then y plus 2y is 3y. So 3y plus 30 is equal to 9.6 times 5. What was 9.6 times 5? 48, so we're going to get 3y is equal to 48 minus 30. So y is equal to 18 divided by 3, so y is 6. Okay, which is then, I'm going to write it just above here. So this one would be 12. Okay, how many marks have I got there? 5. Why would we say 5? 2. I haven't written anything at all explaining what I'm doing. I just need to go and annotate all over why I've done this. So largest was 16. Okay. How did I work out the 4? Range was 12. So 16 minus 4 equals 12. Okay. Median is 10. And then I just need to explain what I've done here. The mean, add for mean, add all numbers together. And then divide by how many numbers. And then I was told this was 9.6. I was given this. Okay, and for me there, the rest is pretty self-explanatory. I'm just solving an equation. I don't think I need to go through and say, take the plus 30 over to the other side. I don't think you need to do that. For me now, that's hitting 7. Okay, maybe if it was me sat an exam, especially if I had a bit of time left over, I'd go and just absolutely nail it and say, look, I'm doing this because, only if I had time. We're looking at 2 minutes there. You shouldn't be spending a long time. If you sat at the end, you're like, oh, I've got 10 minutes left to do nothing, I'm just going to sit here. You might as well go back and show some ink getting written all over this, okay? This one here, I think is quite a tricky one. How do we feel with this one at home? Okay, there's a couple of different ways you can do it. Try and think of the best method. I know the quickest method, but it's not necessarily the easiest method to understand. It says the length of all edges of this cuboid are increased by 20%. Find the percentage increase in the volume of the cuboid. Anyone have a particular method they found easy?
Well,
It's fine if you didn't, it's not a problem. I'll show you the quick method. Shall I show you the quick method or the proper method first? I'll show you what I would do if I was really, really stuck. I'd do it with numbers. Okay? So, if I said this was 10 centimetres, this was 5 centimetres, and this was 4 centimetres. Okay? What would the volume actually be? It would be 4 times 5 times 10, which is 200 centimetres cubed. Okay, so now we need to do exactly the same thing, but we need to increase everything by 20%. So then for my new one, although it's actually going to be smaller where I've drawn it, it's not drawn to scale. So I've got, what, 12? Happy with that? 6? And then 4.8? What would be the volume of that? So I'll need your help here with the calculator, please. 345.6. Okay, so that would be centimetres cubed. So to go and actually work out what the percentage increase is, I would do the difference between the two. So 345.6, take away 200, divide it by the original. It was originally 200, so that would be, what, 145.6 divided by 200, and then times that by 100. Okay, so what does that give me? Again, I'll need that. I can't do that in my head.
So why do you divide by 200?
Because you always divide by the original. Okay, the formula for percentage increase is difference. So if we can move that down a bit. 72.8%. Difference divided by original times by 100 to get your percentage increase or decrease. Okay. So the quicker way of doing it, I believe, would just be doing 1.2 times 1.2 times 1.2. Can you sit that into your calculator and tell me what that is? I'm hoping it's to be 1.728. Is it? Good. Do we know why that works? Do we understand what's going on there? So basically, if you wanted to increase something by 20%, you times by 1.2. And then because I'm increasing absolutely everything by 20%, it's 1.2 times 1.2 times 1.2. So that's telling me that I've increased it by 100%, add 72.8%, which is 172.8%, which comes as being 1.728%. So that's like the quick hand way of doing it, but I don't think it's intuitive at all. I did this way when I first did it, and then I saw that as something that's quite neat and quite clever, and it's for 4 marks. If you get that way, it's obviously very, very quick. But for me, it made more sense to do what I did with the numbers. You'll often find that you can do it with numbers, and the algebra is hard. Okay? Just make sure I am recording. That's good news. I'm gutted if we'd lost that one. Oh, this one's really, really hard. Yeah, this one's hard. Right, I'll stick on this one as well. Okay, so the diagram below shows an ornamental archway which is 8 metres by 6.5 metres. So it's basically just giving us all the information which they've got to put into the picture here. It says find the number of tins of paint needed to cover. So one tin of paint covers 5 metres squared. Find the number of tins of paint needed to paint all surfaces. Okay, so any ideas what our theory is? If we can try and get the theory, then we can start doing it. Rachel?
I was thinking like area or the rectangle, then the circle.
Good. Basically, we're gonna find all the areas first, find out what needs to be painted, then we're going to divide it by 5 because that's 1 tin, so it'll tell us how many tins we need. Now the thing that you've got to get your head around that I did wrong first. Let's call that A. I'm going to paint that. Call that B. Call that C, so we're going to paint the other side of it, aren't we? Call that D, so we're going to paint that side, and E. Are we done? The underside as well. This black bit here, so that'll be F. Okay, so A, B, C are quite easy. D is trickier, and then F is the one that's going to be really, really hard to get our head around. Okay, so if I start doing the work by here, for area A for me, what I've called A, it would be 8 multiplied by 2. No, it wouldn't. Yeah, it would. 8 times by 2. We happy with that? Which is 16 metres squared. And then for B, I can find that area and then just times it by 2 to find out what C is. So I'm going to say B and C. So I'm going to say 2 times. And then that rectangle, 6.5 times 2. So that would be 13, so that would be 26 metres squared. All good? Okay, for rectangle D, that's a composite shape. That's a rectangle with a semicircle cut out of it. So I need to do, so this would be D and D, wouldn't it? So it'll be 2 times whatever I do next. Okay, so I need to do 8 multiplied by 6.5 first. 8 times 6.5. Now that'll do the rectangle. So I need to take away the semicircle. So how would I work out the semicircle? Pi r squared. So it's going to be pi multiplied by, excellent, 2.5 squared divided by 2 because
Semicircle.
it's a semicircle, okay? So basically that line there is going to go into your calculator. So I might grab one so I can do that one as well. Can you all have a check of that one so you can get the same answer as me? There's quite a lot going on there. I've got 84.365. A quick check. Obviously, I could have done something wrong here, so I'm definitely right. Does it make sense as well? That's what you should be asking yourself the whole time. I think it does, is my gut feeling, because that's going to be like 8 times 7, say that's 56 there, but then I'm going to take away a bit of a circle. It doesn't look like a huge circle, and then I'm going to double it. So for me, that's looking about right, that answer. But can you check? I'm not confident enough to write it down yet. Someone else got it, yeah? What should I round it to? Can I round it? I'd say it's probably not a good idea to round it to 1 dp, but to maybe 2 we'd be fine for that, because it's going to be so insignificant by the time we divide it by 5. It's not going to be an issue. And also, what page are we on? Page 12. It's the thing when you try and keep your answer in the calculator is really far down the paper, okay? So I'm going to say 84 points. I'm going to say 365. We're going to go to 3 dp. I think that'll be fine. Meters squared. Okay? And then F. This is the one that's going to be really, really tricky to work out what's going on. What shape is F?
A rectangle.
It is a rectangle. Well done. It's a rectangle that measures 2 meters by this thing flattened out. So what is this thing here? Circumference. Excellent. It's half of the circumference. So it's pi d divided by 2. Okay? So it's going to be 2 times, and then pi times 5, all divided by 2, just that bit there. Do I need to double that?
Sorry, where's divided by 2?
Because it's half of the circle circumference.
Oh, yeah.
All good? In effect, those two 2's are going to cancel out, aren't they? So we're going to get 5 pi, which is 15 points. I'll go to 3 dp again. 708 meters squared. All good? So I'm then going to get a total area of all of those added together. Now if it's QWC, I'd show that I'm adding them all together, but it's fine just to do it as it's not. That comes to a total area of 142.078 meters squared. Again, that's to 3 dp. How are we looking now? Are we almost there?
Yeah.
What would I do next?
Divide by 5.
Good. So 110 equals 5. So if I divide that 142.078 divide by 5, I get 28.4146. Now that's tins of paint that I need. Yeah.
You know, for the calculation for part F,
Yeah.
shouldn't it be 2 pi r, not
2 pi r and pi d are the same formula.
that?
It'd be absolutely fine to use the same one there. Say or 2 pi r divided by 2. Okay?
Yeah.
Well, good. So you can have 2. It's whichever one you're used to. Don't change one. You stick with whichever one you're happy with. Okay. So can I go into a shop and ask for 24.416 tins of paint? No. And if I need 28 and a bit tins of paint, I need 29 tins altogether.
Actually, I'm sorry. Actually, I got that.
Did anyone get that one at home first themselves? No, it's a hard one. That one it's tough. Do you get pretty close?
It's probably calculation error. I was
Yeah?
like 2 off it.
Well, okay. You sound like you're doing all the right
I think it's
things.
4 off. So
Okay.
I said like.
9 marks that one. It was tough. So, you know, lots of marks there, finding the areas and doing all that sort of stuff. Oh, this is a good one. We've been looking at ones like this recently. What's wrong, boys? It's bickering away, going over the microphone. Anyone want to come up and have a go at this one? Paul?
I'll try anyway.
Okay, so to find an area rectangle, it's just length times width. So that would be, we know, so it'd be, the length is x plus 5, so that's x plus 5. And then it's the width, so that's x minus 2, and that's equal to 120 centimeters
Do you need to put centimetres squared in?
squared. Yes.
I wouldn't bother if it's me. I think it would just potentially make things a little bit harder and sort of like take away the algebra that it's going to.
You know, I'll just take away everything.
Sorry, you're doing fine.
I started to realize I might have bitten off more than I can chew, but okay. Here we go. I'm gonna try it anyway. So we need to expand that out. So that would be x squared. Oh boy. X squared plus, and then in brackets, so it's what. Oh, jeez, this was a mistake.
Maddie's a good person to ask if you're unsure.
I know it'd be 10. Yeah, oh yeah, 3x plus minus 10, yep, equals 120. Okay.
If you've done that quickly, I probably would have expanded it and said show plus 5x minus 2x, but it's fine to do that if you're confident enough to go straight to that step.
Now, we can divide.
Again, Maddie's a good person to ask if you're unsure.
We'll see how it goes, sir. Okay, so
Don't take any advice on boys. Fine, you just carry on.
okay, fine, we'll get some advice.
Do it.
You need to put it into a quadratic so you can solve to find x. So you take the 120 over to make it minus 130.
Okay.
So
X squared plus 3x minus 130
Yeah.
equals 0. And solve it.
Oh, I see. That's a weird thing. X squared equals 0. Okay, and then we have to.
Double bracket it.
Oh.
Two double brackets.
Oh yeah, of course. And then we can. Fine. Okay. It's the biggest mistake of my life.
Okay, so you know x and x has to be in front. So this is all about the process now, going through what we need to do.
Okay, so.
So a pair of numbers that time together to minus 130, which sounds horrific, doesn't it? Now, there's only two obvious numbers here, which is 65 and 2, or 10 and 13. So it's probably going to be one of
10 and
those.
13. So yeah, it would be 13 here and 10 here.
Good.
And then we can just say that it would be. So we know that x is either minus 13 or 10. It's a little hard for a dimension to be a negative number because it would cease to exist. So x is likely to equal 10 centimeters.
Very good. Well done. Well recovered. Okay.
So, how do you know
Parallel
when
universe.
How do you know when it'll be quadratic? Well, it's a good indication that you're on number 14. It's got some algebra. You expand them. That if it's got an x squared part and an x part, you want to get it in form quadratic.
Minus 2 log positive 10 if it's plus 13 and minus 10 in the bracket.
He has, yeah, that's right. Hang on, 3, 2, and 1. Thank you.
You don't steal my shoe, man.
Thank you, Paul. So in terms of this here, we knew they timed together to make minus 130 here and added to plus 3. I might even write that by here. Times to minus 130 and added to positive 3. Now what Paul did, and he didn't really sort of go through it, I was really pleased he did it, was when he did his x brackets, he straight away went to a plus and a minus, which we knew it had to be, because it times to make a negative number. So now we're looking for a pair of numbers that times us together to make 130. And like I said, for me, there's only two obvious combinations, which are 13 and 10, or maybe 65 and 2. But 65 take away 2 is 63. So that's miles off what I'm supposed to get. I'm supposed to get 3, so that's no good. sorry, you can't see what I'm doing here. But plus 3 take away 10 is 3, and that's what I wanted. Okay? Does that answer your question or not? Yeah? From the next bit, how did he get the x equals minus 13 when it's a plus 13 up here? Is that the bit you're after as well? Well, this is saying that a number times a number is equal to 0. And the only way to actually get that to happen is that one of these brackets must be 0. So either x plus 13 equals 0, or x minus 10 equals 0. Okay? So take the plus 13 over, it becomes minus 13. Take the minus 10 over, it becomes plus 10. And then my solution is if I chuck in 10 there, 10 take away 10 is 0. 10 plus 13 is 23, but 23 times 0 is 0. Okay, and vice versa if you stuck in minus 13 there. Okay, all good? We now... anyone fancy going up and doing this?
Josh is like our geometry man. I think you should do it.
Josh, the geometry man, you're getting a bit of a following up here. Would you like to go up and do it?
No, thank you.
It's a bit of a mean one to chuck any of you to go. Okay, right, there's two really, really, really easy graphs here. What are the two simple graphs? Yeah. Y equals 3, x equals 4. So, find on the y-axis, find 3. So here's 5. Let's see what I'm doing. Here's 5. What's my scale?
2.
Careful.
Well, no, I have 2 squares.
Oh, sorry, so 2 squares is 1. So I'm going to go to 5 and come back 4. So coming back 1 would be 4. Coming back 4 whole squares would be 3. So then you just go through it. Okay? What should you do once you've drawn that line? Label it. And that's y equals 3. It's not the inequality yet. Worry about the inequalities right at the end. And then x equals 4. So here's 5. Here's 4. And straight through there. So that's x equals 4. Okay, the y equals x plus 7 is quite easy as well. I am going to draw an xy table for it though, just to be sure. So x, what numbers shall I use for x? 1, 2 and 3. You can use any numbers you want, but I go consecutive numbers. I always do 1, 2, 3. So then 1 plus 7 is 8, 2 plus 7 is 9, 3 plus 7 is 10. So I need to go and plot those coordinates. So 1 and 8, 7.5 there. And then 2 and 9, and 3 and 10 there. So although they're all really close together, as long as my ruler goes through them, it's fine, which it does. So that is x plus 7 is equal to y. All good? And final bit. And again, I'm going to go and do an xy table. What value shall I use for x?
1, 2, 3.
1, 2, 3 again. Okay, 1 take away 2 times 1. What's that? Minus 1. 1 take away 2 times 2. Minus 3 and minus 5. Okay, all good? So now I need to plot those. So 1 and minus 1 by here. 2 and minus 3 there. And then 3 and minus 5 here. Okay? Now, if I had to bet my money on it, I'd say it would be this four-sided shape here. Okay? But I don't want to bet money on it. It is GCSE exam. I'm sure I can work it out. It says, especially after I told you I lost all my money in Vegas and all that, so I'm not very good at betting.
You only had $100 on you?
I only had $100 I was prepared to lose.
It's just like, only $100.
Okay, best way to do it. The first two are easy. Y is greater than 3. So that's everything's greater than 3 is up here, but I like to shade out the stuff that I don't want. So I go up to the line there, start shading out all of this stuff here, and that means all of this stuff would be gone as well. Okay? The other one that's easy to do is the x. X is less than 4. So that's all this stuff here at once, so I'm going to shade out all the stuff that I don't want, which is all this stuff to here. Okay? The other ones here, these are your tricky ones. So y is less than x plus 7. So let's pick some coordinates here that we can sub in. And I always go for the origin. If you do the origin, it's quite easy to sub into that. So what are the coordinates there? 0 and 0. Y is 0, x is 0. So chuck in 0, 0 into here. 0 is less than 0 plus 7. So 0 is less than 7. Is that true? Yeah, that's true. So the origin is the side of the line I want. That's good. So that means that I didn't want this side. Okay? And then finally, Let's stick with 0, 0. 0 is greater than 1 minus 0. 1 minus 0 is 0, so 0 is greater than 1. That's not true, is it? So this is only just the side of the line that I don't want, so I want to shade there. So this is my region. Okay? And I think I stole this off Ed, writing in the R there. It says, make sure that you clearly indicate the region that represents your answer. Well, I think I've done that by writing a big R in the middle. Okay? All good? Oh, good. Must be have someone who can come up and do these since me.
I haven't done it.
Go ahead. Have a go.
Who's talking to? Me. Oh. Right. Okay. I haven't done these before, so if I get them wrong, I do apologise.
Doesn't matter. It's just...
Right, 6 and 8. I think 6 goes into both of them, and there's an X here and an X here. So I'd say 6X outside. Yeah? Yeah, I think so. So to get 6X to 6X squared, you just times by X. So, and then to get 6X to 18 would be 3Y, so plus 3Y. Good, we're all good? Good. X squared minus 25. We know that 25 is a square number, and we know it's in the negative. So we know it's going to be X, oops, that's not an X, X plus 5 and X minus 5.
Very good. Not obvious that one at all, because you look at it, there's no letter or number in both. But the fact that 25 is a square number tells you to square root that number. It's what we call the difference of two squares. So one where you plus it, one where you minus it. Well done.
Here, it's just basically, you can pretend this is an equals. So we're going to try to get n on one side. So this is a greater n than this, so we'll just take that away. So we know that 3n, and then we'll take the 5 over there. So 3n is greater than, less than, sorry, 22 minus 5, which is 17.
Yeah.
17, yeah.
So
So
careful, it's a minus 5 on the left-hand side, so you're going to plus it.
oh yeah, so it's 27. Sorry, so sorry. 3n is less than 27, so we'll divide this by 3, and we'll divide this by 3, so n will equal 9.
Careful.
Oh, no, n doesn't equal 9, n is less than 9.
Good.
Oh, watch out.
Any idea how, I knew you'd made a mistake, but not because I'd seen the minus go over, it was actually the next line. You would have got 22 minus 5 is 17. I knew 3 didn't go into 17, I was thinking, has he done that right? And that's how I spotted it. It could be, if you got an answer like that, 17 or 3, and you're pretty certain it is, it could be that that does come up. And then they go and ask you something like, write down the smallest number that satisfies, or the biggest number that satisfies this inequality. But just be certain, if you do get a weird answer, just go back and check. If I've done everything right, is this the right? And if you think, yeah, I have, then it probably is fine. God, are you happy to do that one as well?
I'm happy to do that one. I might need some help though. So this is a basic quadratic.
Good.
So we know that we're going to times the 3 by the 11 to get 33.
Good.
And because it's a positive, it's going to be 2 positives that we're looking for. And they have to add up to 19. So I know 11 and 3.
11 and 3, so 11 add 3 makes 14.
14,
so
that's not going to do.
Next pair of numbers. Don't forget 1 in itself.
Oh yeah, 1 and 33. But that's not really going to work either.
Is there any other pairs of numbers that makes 33?
Oh, are we going to have to use the equation?
Excellent. Now there's a bit of a hint in the question which says correct to 2 decimal places. Okay? If it says that, it's a little bit of a hint that you're going to use the formula there.
Oh, whoops. Yeah.
Okay, so the formula is minus b plus or minus square root of b squared minus 4ac all over.
2a.
Why is it only 3 marks? It's such a long, like, thing.
It's time consuming, I'll give you that. The best thing you can do here, David, is writing on the left hand side, write down a equals, underneath it, write down b equals.
Right, so if we write out the equation, 3x squared plus 19x plus 11, and we're looking for a, we're looking for a equals
underneath it, write b equals, underneath it, underneath a.
Oh, right, okay. So we know that a is going to equal 3. Wait, what do you mean underneath it?
So write a, I'll write this bit, you do it fine. You're doing all the hard stuff, don't you?
Oh, I see.
Okay. I always recommend doing that.
So A is going to equal the 3. Before it is a plus, so we're fine just to leave it as a 3. 19, there's a plus before it, so we're okay to leave it as a 19. And 11 also has a plus before it, so we're okay to leave it into an 11. So then we just going to sub everything in. So plus minus 19 times the square root of 19.
Why is it plus minus?
No,
It's just a minus.
Oh.
Plus and minus is take away, but
It's plus minus 19 plus minus square root.
yeah. Sorry.
What?
Just grab the pen. Only took a second.
It's minus 19
Plus minus there. Oh, okay, all good.
Cheers, guys. Plus minus here. 19.
It's minus
What now?
It's minus D in the equation.
Oh, right. You should have said minus 19 plus minus the square root. So 19 squared minus, and then I usually put this part in a bracket.
Good.
Do you put the minus in the bracket as well?
Yes. No.
No. Yes. No.
No.
No. Okay. So 4 times A, which is 3, times C, which is 11. Close bracket. All over 2 times A, which is 6.
Good. And then you do once or you add it, once or you take it away.
Yeah. So
Go on, swap basically, well done.
you can swap it.
Anyone got the answers to that for me? Minus 0 points to 2dp and minus 5.69 to 2dp. Okay, all good?
So you know the part C.
Yeah.
How do you know when to flip the sign over?
When to flip the sign over is if you ever get a negative one of these, which is why David said, look, let's go and choose n because it's smaller than 4n. So if you make that conscious decision, then you never actually have to worry about that. If you had it like, say for instance, I had something like 2n plus 5 is less than 5n minus 4. You see that fine there? So if I said, look, let's take the smallest n over, so let's take that over, so we're going to get the minus 4 coming over to being plus 4, so we get 4 plus 5 is less than 5n minus 2n, which is 9 is less than 3n, which is 3 is less than n. Are we happy with that?
Yeah.
You can leave your answer as that, that's fine. We're just used to seeing the n being on the other side, so if you then want to flip it, you must flip the inequality then. Okay, but this bit here isn't needed. Those two things there are the same. You'll get the marks either way. Okay? Okay, and so the key word I've already seen is histogram. Look at that, looking at this. It looks like it's going to be a bar chart. It's not going to be when you're on page 17. Okay? That's your hint there. You're on page 17. It's going to be hard. Histogram. FD equals...
F over CW.
Isn't that right, Maddie?
No.
Yeah.
GW.
This came up in the paper I did on YouTube, which says find the median. Okay. So what you do is you know that there's 100 people, so the median is 50th person, and it will always be that some of the numbers add up to 50 somewhere bang at the end of a category. So 6 plus 19 is 25. 25 plus 25 is 50. So these 6 people I expect to be sort of like evenly distributed between 0 and 10. So I'd expect one person like to do it really quickly, 2 people to do that twice the time, and so on. So by the time I get to the 6th person here, I'd expect him to have taken 10 seconds. By the time I get to the 25th person, I would expect him to take 20. And by the time I get to the 50th person, I'd have expected him to take 13. Can you see the number sort of overlaps in both columns? If it comes up, it will always be that it works out like that, okay? So that would equal 30 seconds, okay? Draw a histogram to illustrate the distribution on the graph paper below. Okay, so what I would do is I'd write here CW, which would be 10, 10, 10, 10, and then 20 at the end. And then I'd write down the frequency density here. I'm sort of regretting writing those numbers in there now. There we go. So 6 divided by 10 is 0.6. 19 divided by 10, 1.9, 25, 2.5, and 3.6, and 0.7. Remember, you've got to calculate it for that bit as well. So looking at my graph here. Now, a little bit concerned looking at that. I'm thinking, oh, have I messed up my scales there? Let's just check. That is definitely 10, isn't it? That is definitely 3.6. That is definitely 2.5. So I felt 2.5 is going to work quite nicely with that scale. Well, obviously I can't go up in ones, can I? Because my biggest answer is 3.6. So what am I going to go up in? Go twos, 2, and then 4. And that should be fine, shouldn't it? And that would be my frequency density. So I must label. Okay. So for the first one, 0.6, that's just going to be 3 bars up here. So I go and draw all the sort of horizontals, and then I just draw the lines after. Then 1.9, so that's going to be just under the 2, halfway there. Then 2.5, so that's going to be 2.5. There's it, 2.5. And then 3.6. And then the last one, 0.7. 7 there. Okay, so I've got it like that, and now all I do is just go and draw down. Bit of a fussy scale to give you there, that's a bit mean, that one. I didn't like having to draw them halfway in between. Okay, all good? Oh, fantastic. Frustrum. How do you do the frustrum question? Can you remember what we do? Mitchell? Excellent, very good. It's a cone, so
I got this one.
it's a cone with the top cut off, so it's sort of like that. But how long is this red line, this height that I've just drawn in?
6 centimeters.
Are you sure?
Yes.
Why?
Because if you look, the radius decreases by 1. Like, and then it's like
The radius is decreased by 1?
decrease in radius is like half of what the increase in height. Like every 2 centimeters.
You don't sound uber confident, James.
No, if for every 2 centimeters it goes up, the radius decreases by 1.
How do you know that?
Because I did 10 divided by the decrease in radius.
So, oh right, okay, so
Step
10,
up or rise.
so there's a decrease in radius of 5 centimetres, so 10 divided by 5 is 2. So what, every time you go up 1 centimetre, you're decreasing. I don't know if that works, James. How confident do you feel with that theory?
Yeah.
Was it you just had a bit of a bash in it, you weren't sure?
Yeah.
I know my way definitely works. I've never heard that one. I'd have to sit down and have a really good look, thorough look. But you may well be right, okay? I'll have a look after the lesson and see if it does work. The way I was going to do it was similar triangles and say that is a height I do not know. So that would be x by 3. And then this one would be 8. What would this length here be? Careful. 10 plus x. Very good. Okay, so we know that's 10 from before, and the x gives me a total of 10 plus x. Okay, so can you remember when we did similar triangles? I said, look, you can go and find the scale factor, but sometimes you'll need to use the theory way. Well, this is the theory way. If I say this line here divided by 3, it must be the same as this line here divided by the corresponding. Okay, so it would be x plus 10 or 10 plus x over 8. Are you happy with what I've done there? So this one standing up divided by the base is the same as this one standing up divided by the base, as long as I do it in the same order. Okay? Any idea what I do now? Rearrange. Take the divide by 8 over to this side, we'll times by 8. Take the divide by 3 over, it will become a times by 3. In other words, cross multiply. Okay, so I'm going to get 8x is equal to 3x plus 10. All good? So that's going to give me, I'm going to have to start writing a little bit underneath now. It's going to give me 8x is equal to 3x plus 30, 5x equals 30, x equals 6, which is what James had as well, wasn't it? Yeah? Now, I'm not 100% certain on James's way, so I'm going to have a look at it. I know this way 100% works every single time. I'll have a look at another one, James, and see if your way works then, and if it doesn't, you found quite a nice quick way. Okay? So, what I need to do now is work out the volume of this really, really big imaginary cone, the top that I've added on, and then take away this bit that I have added on to find what's left in the base. Okay? So if we call big cone, what is the volume of a cone? What's the formula?
1/3 pi r squared pi.
Good. Okay? So that's going to be 1/3 pi times 8 squared times by. Now we know x is 6, so 10 plus 6 would be 16. Okay? So that would be whatever that is. And then to do the small cone, that's going to be 1/3 pi times radius squared, so this time times 3 squared times 6. And that is whatever that is. So then you do that one, subtract that one. Okay? So I make the first one being 1072.33 blah blah blah, and then I'm going to do answer take away 1/3 pi times 6. Right, I've got my overall answer as being 1015.8 centimeters cubed. I wouldn't mind going and working out what that one is. That's not right. Still not right. Messed everything up now. Yeah, that comes as being really small, that one. It's only 56.54, blah, blah, blah. Okay? So that's what I've got the overall volume as. Okay? I think the bell's going to go any second now. We've got pretty close there. We can look at finishing those two off tomorrow, okay?
So tomorrow we're sitting here the whole day.